Now let us study the another type of digital to analog converter, that is R-2R ladder type. R-2R ladder type digital to analog converter. R-2R ladder type digital to analog converter. This digital to analog converter is also called as binary ladder. It is also called as binary ladder. So this binary ladder uh, this binary ladder type digital to analog converter, the output voltage VA, the analog output voltage VA is the properly weighted sum of the uh, each digital input, properly weighted sum of each digital input. Okay, the analog output voltage is the properly weighted sum of each digital input. So this ladder uses this ladder uses registers of only two values, R and 2R. Only two types of registers are used, R and 2R. So here 4-bit binary ladder is shown, DCBA, and therefore uh, DCBA are the four that it is a 4-bit type R2R ladder network. This is a 4-bit R2R ladder network, and its output voltage VA, it is in between point N and ground. The analog output voltage VA, it is taken from point N and ground. That is, VA is in between point N and ground. Okay. So the DCBA are the digital inputs or binary inputs applied to this ladder with the positional values of 2 raised to 3, 2 raised to 2, 2 raised to 1 and 2 raised to 0. Here D is the MSB point and A is LSB point. So the positional values of digital inputs are 2 raised to 3, 2 raised to 2, 2 raised to 1 and 2 raised to 0. Okay, the analog output voltage, it is taken from point N and ground. Now let us assume that all the digital inputs are connected to ground. All the digital inputs are connected to ground. Then resistance between point K and ground is 2R. Resistance between point K and ground is 2R. And now since a point terminal A is also connected to ground, therefore the effective resistance becomes twice R parallel twice R, that is R. Means uh, the network to the left of point K is R, that is twice R is, this twice R comes in parallel with twice R, which becomes R, the effective resistance becomes R. Now this R and resistance between terminal K and L is also R. So this R and this R comes in series and it becomes R plus R, R plus R 2R, R plus R 2R, and the resistance between terminal B and L is also 2R, and terminal B is again connected to ground. Therefore twice R comes in parallel with this twice R, it becomes R, twice R parallel R, twice R parallel twice R is equal to R. Again this R comes in series with R, so R plus R twice R. Again this twice R comes in parallel with twice R, and its equivalent resistance is or effective resistance becomes R. Again this R comes in series with R, and it is R and are in series, so it is twice R. Again this twice R and twice R which is connected to the voltage source D, twice R. So the twice R and this twice R are in series, and so VA is equal to twice R divided by twice R plus twice R into V. Okay. Now since D is also again it is at a ground potential, so VA is equal to 0. That means when the digital inputs are 0 0 0 0, then VA is equal to 0. VA is equal to 0, and the formula for the analog output voltage VA is equal to V0 into 2 raised to 0 plus V1 into 2 raised to 1 plus V2 into 2 raised to 2 plus V3 into 2 raised to 3 divided by 2 raised to n. The second formula or another formula for the analog output voltage is given by VA is equal to V upon 2 raised to n into count. V upon 2 raised to n into count. Now let us now take one example. Let the digital inputs to the ladder is DCBA is equal to 1000, where D is the MSB point and A is LSB point. So the ladder is shown here. So since A, B, C are 0 0 0, therefore these terminals A, B and C are connected to ground. Okay, and D is at high potential, that is D is equal to plus V. Okay, now here twice R comes in parallel with twice R, because this twice R and twice R are in parallel. So twice R parallel with twice R, it becomes R is equal to R, and this R is in series with R. So R plus R, twice R. Again this twice R is in parallel with twice R, it becomes R, and R plus R is in series with R, so it becomes twice R. Again this twice R is in parallel with twice R, which is in between points C and N. So twice R parallel twice R, that is R. Again this R and R are in series, so R plus R, twice R, and therefore twice R and twice R are in series. So VA is equal to twice R. By using voltage divider formula, VA is equal to twice R divided by twice R plus twice R into V. That is twice R divided by 4R into V, that is equal to plus V by 2. So twice R divided by total resistance twice R plus twice R into applied voltage V. So twice R upon 4R, that is V, that is 1/2. Twice R upon 4R means 1/2 into V, that is plus V by 2. So VA is equal to plus V by 2. Okay. So this can be solved by using this formula. Here VA is equal to V0 into 2 raised to 0 plus V1 into 2 raised to 1 plus V2 into 2 raised to 2 plus V3 into 2 raised to 3 divided by 2 raised to n. So here V0 is equal to 0, V1 is equal to 0, V2 is equal to 0, and V3 is equal to 1. V3 is equal to 1. So here 0 plus 0 plus 0 plus V3 into 2 raised to 3 and divided by number of n means number of bits, that is 2 raised to 4 means 16. 2 raised to 4 means 16. So 2 raised to 3 means 8. So 8 upon 16, that is 1 half. So V3 upon 2, that is V by 2. Okay. This can also be solved by using this formula. Va is equal to V upon 2 raised to n, where n is the number of bits. There are 4 bits, 1, 2, 3, 4. So V upon 2 raised to 4 means 16. So V upon 16 into count. Count is 1, 2, 4, 8. So count is 8. So 8 upon 16, that is 1 half, and into V, that is V upon 2. V upon 2. So V is equal to V upon 2. Okay. So this is about R-2R type ladder, R-2R ladder type digital to analog converter. So we will stop here.